Okay, good morning, all the students. Let us today deal with satellite image analysis. Okay, generally, you might have seen where you find lots of images, mainly in, say, agricultural prediction, or say forest cover, or where the forest fire is prevalent. We might have heard to forest fire incidents these days in California, in Australia, right? So geographical scientists want to understand what is the geographical orientation which leads to this kind of forest fires. So if they're able to understand about a geographical area and what are its parameters, analyze the images, satellite images of those geographical locations, they would be able to draw some inferences with respect to why the forest fires are actually spreading, or what is the land forest cover in particular region, how fast deforestation is happening. Yeah, we might have listened to deforestation of Amazon forest, right, which is actually reducing the forest cover on the earth. So they are trying to study all these. They can't do it at a micro level, so they're doing it at a macro level by performing satellite image analysis. So we are today going to see about one such kind of satellite image analysis using this Numpy. So the data source we have taken here is satellite image from wildfire project, because this wildfire is an integrated system for wildfire analysis with specific regard to changing urban dynamics and climate. So how the urban dynamics are changing. Urban dynamics means the land cover, the forest cover, the temperature in that area, the density of population in that area. All these are urban dynamics. So based on that, how the climate is getting impacted, how the meteorological conditions in an area is getting influenced. Okay, such kind of studies can be made by using this satellite images. The system integrates networked observations such as heterogeneous satellite data and real-time remote sensor data with computational techniques in signal processing, visualization, modeling, and data assimilation to provide a scalable method to monitor such phenomena of forest fires as particular weather patterns, which can help to predict uh, wildfires rate of spread, at what rate they are spreading, how much forest fire the cover is being destroyed because of this, at what rate it is being destroyed, and how many days it takes to get it into control. Such kind of analysis can be done. Now if you want to just go through, if you are interested in this, you can just go through this link where you can read more about this forest fires. Now in this example, we are going to analyze a sample satellite image dataset from wildfire using the Numpy libraries. In order to work with this satellite image analysis, you need to import these libraries. Okay, this SciPy library at present is not required. In the previous versions, in order to load the data, we used to use this SciPy. Now it has become obsolete and we just started using image.io instead of this SciPy. Okay, so I just deleted that package, that library. Now see this command. This is preceded with a percentage symbol. This is called as magic function, which will get the matplotlib library inline in order to work with it in the Jupyter notebook. So if you want to get any libraries inline into your Jupyter notebook, import it into your Jupyter notebook. One way is to use these magic functions. Also, we can use import. Just to make you know about these magic functions, I just have included this command, percentage matplotlib inline, then also import numpy library, because every image is collection of pixels stored as multidimensional data, which is again an interpretation of a new matrices, right? So we want numpy library to work with it. That is why you are importing the Numpy library. And to perform any visualizations or to show the graphs, you may require this matplotlib.pyplot. So we have given a short alias name for it as PLT. We are importing all these libraries. Execute this by pressing Shift Enter. Now let us see how to create a Numpy array from an image file. Generally, images are saved with .jpg extension, right? So when you want to work with analyzing the images, then you have to create a Numpy array out of this image file. Means every pixel is considered to be of element in the Numpy array, right? In the n-dimensional Numpy array. Now for this, initially import the image IO in order to read the image from external source or from your system into your Jupyter Notebook environment. You have to use this image IO. So import it. Now see what I'm doing. I'm using this image IO libraries image read method. IM read is image read method. And using this image read method, I give the path to this uh, image file. Okay, so I'm giving some relative path here to the image file because it is on my system, or you can also give the exact path. Say this layers is saved in my downloads in STP file, and in this STP file you have in day one in wildfire folder. Say I have a file here, just right click on it, go to properties, you will have the path here, right? Copy that path. It will not include the file name. Just copy the path and come back to your Jupyter notebook, paste the path here and give the file name. All the backward slashes in the path should be replaced with forward slashes. And you have to finally give this file name st3layers.jpg. Okay, now this path helps you to read the file, read the image into your local object. So this is a Numpy array. Photo data is a Numpy array object, n-dimensional array object into which the image will be read in the form of rows and columns of pixels. Did you understand that what I'm trying to tell? You are reading the image from a path and that image is being stored in an object. What kind of object it is? See, let us give here type of photo data. You can see this is of type, this image that is retrieved into the local object photo data is of type array. Array, what kind of array it is? N-dimensional array, which contains rows and columns of pixels. Let me clear this output. Yes, now let us run one after the other. Now this will give the type of photo data as image IO core utility array, which indicates that the image that is read into our local object photo data is now of type array. We are now creating a Numpy array from the image file using this, right? Now, if you want to print this data, sorry, if you want to show this image on your Jupyter notebook, you have to use plt.figure. First, reserve the space to display that image. Okay, that can be reserved by using plt.figure, and you can reserve the size for that figure. This is again optional. If you don't give this, it just gives the default size for the figure, number of rows and columns. It will adjust in a decent manner to understand, to look at the image clearly. Okay, that is optional. But generally, we try to mention. We try to mention the figure size by giving how many rows it should span and how many columns it should span, right? So we take the figure, we reserve the space for the figure, and you use plot.imageShow, IMShow. IMShow will show the image that is stored as an array in photo data object. Understand these terminologies carefully. If you don't understand these terminologies, you tend to treat this photo data as a variable, uh, actually, which is a wrong interpretation. Okay, so in Python, you should treat every variable as an object and every type as a class. I'm repeating this again. Okay, now after you reserve the space here, in order to read the image you are using image read. But to show the image, you are using IMShow, image show. When you use plt dot image show photo data, you can see that the image is being displayed. Now you can see a colorful satellite image is being displayed here with different combination of colors. In satellite images, generally each color will represent some concept. Say red will represent the altitude. Green will represent the slope. Blue will represent the aspect. Like that, as per the domain knowledge, you can acquire this domain knowledge by talking to the domain experts. They will explain you which color represents what in an image. Based on that, you can start analyzing the data. So this is the basic image that is provided. Now, if you tend to see what is the shape of this photo data, what do you expect? You have to expect all these pixels stored in the form of rows and columns. So how many such rows and columns do you have that can be obtained by using photodata.shape? So when you give this, you can see that this image spans across 3,725 rows and 4,797 columns with 3 layers. I'll shortly explain you what are these 3 layers. So this image contains 3,725 multiplied by 407.97 columns of pixels, and they are spread across 3 layers. You have such layers, such 3 layers. Okay, in every layer you have 3,725 multiplied by 4,797 pixels in every layer. You have 3 such layers. One represents red layer, one represents green layer, and one represents blue layer. Right? So these represents the RGB color mapping. So red, green, and blue are the primary colors, right? So these layers represent those primary colors. Now, if you take the scale or if you take the range of these colors, they generally lie between the intensity of 0 to 255. So if I say that a red pixel, a pixel at a particular location is having the intensity of 250, 100, and some 13. So this corresponds to red color, 100 corresponds to green color, and 13 corresponds to blue color. So if a pixel is having this value, then it indicates that pixel is predominantly exhibiting red color. But if you take 100, some 10, 20, and 190, so this indicates red color, this indicates green, and this indicates blue. Now in this particular pixel, blue color is predominant. Blue color is being exposed more when compared to other 2 pixels because they are of very less intensity. Okay, so this is having higher intensity than that. So blue color is predominant in this pixel. That is how we need to understand the color mapping from primary colors to intensities of pixels. The intensities range from 0 to 255, 0 indicating black and 255 indicating white. Maximum intensity, 0 indicating minimum intensity and 255 indicating maximum intensity. Now, if you take RGB, all three colors, if they are set to 255, means all three colors are set to maximum intensity, that will result in white color. And if all the intensities of RGB are set to 0, then they represent black color. You might have noticed in your school days when you turn the wheel of colors very fast, it will be visible as white color, right? So if you mix up all the colors with complete high intensity, then it will result in white color. And it all minimum intensities that will result in black color. Okay, so this knowledge is now useful for us to work further on image analysis. Right? So we have such pixels arranged in 3 layers. Okay. Now here we have given some details about what each color indicates. Red pixels generally indicate altitude, the height from the sea level. Okay, our Bangalore is situated at greater height from the sea level. That's why we have cool temperature. Even in summer, it is not too hot for us. But when you take coastal areas, generally they'll be very near to the sea level. That's why it is very humid there, very hot, always sweating, right? So if altitude increases, even the speed of the wind increases. As you go, you can see at the ground level, the breeze will be very slow. But when you go to the tip of a mountain, as the altitude increases, even the wind speed increases. All this matters in spreading the forest fire. If the wind is very high, forest fire will spread at high speed, at high rate. If the winds are lesser, then forest fire will spread at lower rate, lower speed. Right? So altitude plays an important role in the spread of forest fire, and even the slope of a region. The slope, if it is too steep, then the forest fire may end there itself. If it is not very steep, then the forest fire may continue. Like that, they can draw different kinds of inferences by analyzing colors from these images. Blue generally indicates aspect. Aspect means some very, say, important concepts about a particular geographical region. Okay, so these aspect can be represented with blue color. Now, if you want to see total how many pixels are there in the photo data, then we use photo data dot size, which will give you the product of these two spread over 3 layers. Okay, so that will be the total size. If you have a two-dimensional matrix of size 3 by 2, then total you have 6 elements in that, right? That is the size of the matrix. Here you have photo data dot size, which will give you the size of that entire image turned into Numpy array. Now, if you want to know what is the value in this array, so you can find it by using what is the minimum and maximum value. You can find it by using photo data dot minimum and photo data dot maximum. We know that the color intensities range between 0 and 255. So you expect the minimum value to be 0 and the maximum value to be 255. So whether it is correct or not, we can just execute this and see that all the minimum intensities, all the intensities lie between 0 and 255. Okay, then the image is recorded correctly. Now, this is some meaningless operation, but just if you want to find mean of all these pixel value, pixel intensities, you can just give and see that the intensity, mean intensity of the entire image is around 75. Means most of the pixels tend towards black color. That is why the average has been dragged down to 75.82. That is how we can understand from the mean. Now, if you want to get the value of a pixel at 150th row and 250th column, you know that the image is converted into a n-dimensional array with these many rows, these many rows, these many columns across 3 layers. Now, in that matrix, if you want to get the value at 150th row and 250th column, we get the intensities of that location. So in that location, 150th row and 250th column, the red intensity is less, green intensity is also less, and blue intensity is predominant. Means that pixel exhibits blue color more when compared to other colors. Okay, this is how we analyze, how we access individual pixel values. Now, if you take at 150th row, at 250th column, on the first layer, what is the intensity? Means you are referring to 150th row, 250th column of the array, and you are referring to green color. That green color's intensity, only the green color's intensity you are trying to find. So when you execute this, you will get 35, right? So the green intensity in this is very low, that it is always available here. You can see here that the intensity at that pixel for green is 35. That is what is given here also. Now, if you want to set a pixel to all zeros, let's see what will happen. Now load the image once again. If you make some changes to the image, better load it once again to see the fresh changes. Otherwise, it will embed the changes on the previous changes where we can't clearly notice what is the change made. Okay, so we can just reload the image once again, and for this pixel, 150th row and 250th column, you are making that pixel value as 0. Means you're completely making that pixel value as black, and you're once again displaying the image. Now you can see somewhere around here, 150th row, 250th column, somewhere here, you're making it black. But because already that area is black, you can't notice any change. But let us do some more amount of change so that it is visible. Now let us take here this value. From 200th row to 800th row, all the columns, the first layer, make all that intensities to be 255. Means you are setting maximum intensity and making it as green. Okay, so that green intensity you are setting it to the maximum between this area. Okay, I'll explain you once the picture is displayed. Now here you can see that from 200th, here it is 200th row to 800th row, across all the columns spreading horizontally, you are setting the green intensity. You have selected the layer 1. 0 layer indicates blue, 1 indicates green, 2 second layer indicates blue. So the green you are setting to maximum intensity. That is why you can see a band of green color being displayed on the image. Got it? Now, if you do not give any layer, but setting all the intensities, all the pixel intensities between 200 to 800 of all the columns, means the entire horizontal range, irrespective of the layer, all the layers, red, blue and green layers, you are setting it to maximum intensity. Means red color, blue color and green color set to maximum intensity 255 will give you white color. So this will display a white band across. Did you notice this? From 200 to 800 column, 200 to 800th row, across all the columns, it displays a horizontal band. And all the intensities of red, blue, and green are assigned with maximum intensity. That is why it is showing white color. In the previous case, we have selected only the green layer and has set that to maximum intensity. So you are getting a predominant green band, but in this case, you're getting a white band completely. Okay, now if you want a black band, what is the solution? You can select an area where you want to display the band. You select that specific rows and across all the columns, irrespective of the layer, you set all the layers, means red, green, blue layers, intensities to 0 instead of maximum intensity. So red set to black, green set to black, and red set to minimum intensity, green set to minimum intensity, and blue set to minimum intensity. It will display a black band across the image. Now when you execute this, you can see a black band is being displayed across it. Got it? Now if you want to pick all pixels with low values and suppress them and project only high pixels, what is the use of this? You can get a more clear picture, right? Say if you have black color and near black color pixels. In that case, if you suppress the near black color pixels, this black will become more exposed. If you say have near red color and red color pixels, now if you suppress this near red color, this red color will be more visible, more exposed, more exhibiting. Okay, so that will give us more clear picture about the image. In order to do this, first you have to apply filters to it. So reload the image and create a filter. How do you create this filter? Take the photo data, means all the array values which are lesser than 200. Means in this photo data, you have all the image values, right? Image pixels. Now these pixels, from this array of pixels, you pick all the pixels that are having intensities lesser than 200. Name that filter, name that expression as low value filter, so that all the pixel values lesser than 200 are low values for us, which we are not interested in. So that if you are able to suppress that, other higher pixel values are more visible to us. Okay, so we take this photo data lesser than 200 values, make it as low value filter, and just get the shape before and after. In both the cases, the shape is the same because still we haven't applied the filter, but we just selected the filter. Now, how to filter out these low values? Apply this low value filter on the photo data and suppress all of them by assigning 0 value to it. How do you do that? Now, just display the picture before filtering the pixels and after filtering the pixels. Now, how you are applying the filter is this command. What do we do here? On the photo data, understand this carefully. On the photo data, you are applying low value filter. What is the low value filter? All pixel values lesser than 200. So all values, all pixel values having intensities lesser than 200, they are now completely made as 0 in the photo data array. Right? Now, when they become 0, other high intensity pixels can be visible more clearly for us in order to draw various conclusions. Right? That is how we are filtering out low pixel values. Now, when you see this being run, you can see this is the original image and this is the image with filtered out pixels. Now you can see that all the light color red, blue and green values are suppressed and made as 0, and only higher intensity pixels are projected more, which gives us clear picture about what is the altitude in that region, what is the aspect in that region, what is the slope in that region. That can be studied very well from this picture when compared to the previous picture. Okay, this is how you can analyze the images. Now, if you want to just refer to some diagonal values in the image, what are diagonal values? Where the row and the column value is the same, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. I matrix you have seen, right? I matrix will give you diagonal matrix where all the diagonal elements are set to 1. Now here what we are doing is just find out length of the photo data, how many values you have, and set it as the row range, and column range also let it be the same. Now whenever row range and the column range, if both the row and the column values are the same, set those pixels to, we just run this, and set those pixels to 255. Means you are trying to access the diagonal pixels, and all those pixels you are trying to give it a maximum intensity. When you're giving maximum intensity, it turns out to be white. So you are expecting now a white line along the diagonal of the image. So when you execute this, you can see a white line being displayed across the diagonal orientation of the image, right? This is how we can perform different kinds of operations on the image because you have turned it into an n-dimensional array. Now, how to further process this satellite image? You can process red pixels, green pixels, blue pixels separately. Now reload this image once again because you have made some changes already. Just nullify them, reload it once again so that you can see the new changes made to it. So after reloading the image, see this command. On the photo data, for the entire rows and columns, on the 0th layer, means on the red layer, you are taking all the red intensities that are lesser than 150 as the red mask. Okay, so all red intensities having lesser than 150 value will be now put into red mask. Means you're putting it as a filter. Now take all those values, apply that red mask, apply that red filter on photo data, and wherever the values are lesser than 150 intensity, you're setting it to 0. Right? Got it what we are trying to do? You are taking all the intensities across rows and columns in the red layer, and wherever the intensities are lesser than 150, means the lower intensities, you are setting them completely to 0 so that only the high intensity red pixel values will be projected in the final image. Okay, so you're applying the mask on the photo data and making it as 0 and display the image. Now you can see in this case, all the red intensities, only high intensities are visible in this, and other intensities are suppressed, lower intensities are suppressed, so that you can have a clear picture about the altitude in that particular region. The same thing can be done with green color. You can create a green mask by taking photo data across all the rows and columns, select the green layer, and where the intensities of this green layer are lesser than 150, that should be your filter now. We have named it as, to be more appropriate, we have named it as green mask, right? Or green filter, any name you can give. Now these pixels are accessed and they are kept in an object green mask. This is again a part of the array. What you're doing here, performing array slicing. Did we see the array slicing in the previous session? So you are trying to pick out some pixels where the intensities are lesser than 150 in the green layer here. Okay, so that slice you're storing it as green mask. Now, from the photo data, you're referring to that slice and making all those lower green intensities to be 0 and display the figure. So when you execute this, you can see that all the low green intensities are suppressed and higher intensities of green color are projected to make a clear study about the altitude in this geographical region. Now let us see how blue mask can be created. Now when you want to create a blue mask, you have to again refer to all rows and all columns, and you are referring to this blue layer. Now this blue layer, wherever the intensities are lesser than 150, those are being taken as the blue filter or blue mask, and that blue mask you are applying. Let us just apply it. Just apply that blue mask here and make all the lesser intensities of blue to be 0 and just display the image. Now you can see that only the blue aspect is predominant in this satellite image and all the other low intensities are suppressed. Low intensities of blue are suppressed and only high intensities of blue are projected, right? So this is our final operation on this satellite image. In this case, we can combine all the three masks. Say if you want to suppress only some amount of red and green colors and more intensities of blue colors, you can just create a mask like this. Red mask, all red intensities lesser than 50, all green mask, all intensities lesser than 50, blue mask, all intensities lesser than 150. Right now you have created these three filters, and these three filters can be applied at a time on the photo data or on the image. How you can do that? By using the Numpy arrays logical AND. So you use np.logical and you combine red mask, green mask and blue mask together. Logical AND will combine all these filters together, and that you are combining it into a final mask. Okay, so this final mask will now, it can be applied to reduce lesser intensities than 50 for red color, lesser intensities than 50 for green color, and lesser intensities than 150 for blue color. Okay, so that is your final mask now. And when you are applying this final mask on photo data on the array, you are setting all those lesser intensities, red, green, and blue lesser intensities to 0, so that only the higher intensity values are visible. Now, when you execute this, you can clearly see that only the high intensity red, blue, and green colors are visible on the image. Based on this, the geographical experts can take some decisions why the forest fire is spreading in this region, whether altitude plays an important role, or whether slope plays an important role, or whether aspect in that area has some significant role in spreading the forest fire or in the rate of spread of forest fire. That kind of important decisions can be made, inferences can be drawn by performing this kind of satellite image analysis. Okay, so this session is complete. You can also try to now take some image and perform this kind of analysis, or you can take your passport size photo and try to perform this kind of analysis on that, and you can suppress some pixels and project only some pixels and make a sketch out of your passport photograph also. That is possible. Okay. So from the knowledge that you have drawn from this session, you just try to change your passport size photograph into an image by using this kinds of commands and see how good it looks. You need not rely on any apps on your mobile to change your photo into a sketch. You can just do this kind of analysis by yourself. You can develop an app actually to convert any image into a sketch, right? So let us end this session here. We'll start the next session with pandas data structures, series and data frames.